Welcome to the Summit for Wellness podcast, where we help you climb to the peak of your health. And now, here is your host, Brian Carroll.
Back in 2003, the Human Genome Project was completed. If you don't know what the Human Genome Project is, it was an international scientific research project that sole purpose was to map out the human genome, which first began in 1990. 13 years later, the project was finally complete, and since then, researchers have been working hard to try to understand exactly how these individual genes work and what can influence them. What's up, everyone? I'm Brian Carroll, and I'm here to help people move more, eat well, and be adventurous. And in this episode, I have Dr. Yael Joffe on the show to talk about nutrigenomics, which is how nutrition can impact your genes. All the research around this topic at this point is very complicated, and there is still a ton that we do not know. But Dr. Joffe does a fantastic job of sharing some of the information we currently do know and what you can do with that information. Before we dive into this episode, I have been seeing so many people right now having issues with muscle cramps, which is an indication that your electrolytes are out of balance. I have been testing out a new electrolyte product called Element, and so far it has been fantastic. I usually only like to drink water because I'm not really a big flavor type of person, but their flavors are really good. I'm a fan of the raspberry salt flavor, and Sarah really likes the orange salt. Element is also low carb, sugar-free, and has no questionable ingredients, unlike a lot of other electrolytes out there. So to try out Element, go to summitforwellness.com/LMNT. Now, let's get into my conversation with Dr. Yael Joffe. In the rapidly evolving discipline of nutrigenomics, Dr. Yael is globally acknowledged as a leading expert in the field. She is a highly sought-after speaker, has co-authored 2 books, It's Not Just Your Genes and Genes to Plate, and has been published in multiple peer-reviewed scientific journals. She is the co-founder and chief science officer at 3x4 Genetics. Thank you for coming on to the show.
Thanks, Brian. Great to be here.
Of course, and I'm excited to chat with you about genetics and, a lot of the new science coming out about how we can use that to kind of create a health journey for people. But before we get to that, let's learn a little bit more about you. What's your background and what got you into all of the nutrigenomics stuff?
Okay, great. Great place to start because it is relevant. I actually started off in architecture and not in genetics. So there's a story, and the story is that my grandmother died from cancer when I was a student in architecture. And this is in the 1980s, and there wasn't a lot that people understood about cancer, and they definitely didn't understand the idea that you could eat differently or live a different life and try to prevent cancer. And if you did get it, you could treat to a degree with diet and lifestyle. And I was absolutely devastated by her death, and I was really quite horrified that there was nothing anyone could give us in terms of what she could have done differently or lived differently or how we could have even treated her differently. And so that was kind of the tipping point for me on setting me off on a very different journey. So I left architecture and I went off to find a degree in health. In the 1980s, that wasn't so easy. And the closest thing I could find was dietetics, which turned out not to be about health at all. And I discovered that very soon in my degree that, when they were dishing up chocolate cake and ice cream for patients in hospitals, I realized that health really didn't have a part of how dietetics was taught. Anyway, I got my dietetics degree. I didn't enjoy it. I was very frustrated. I was extremely disillusioned by the way nutrition was being taught and practiced. And so I did what every good person does when they finish the degree. You get a backpack and you go traveling. And I landed up in London. And then when you're in London, you have to make money to travel some more. And while I was working for a nutrition clinic in Harley Street in London, I met an extraordinary woman who had started an extraordinary company. And it turned out to be the first ever company in the world that looked to put together nutrition and genetics. This was the year 2000. And if you think that the Human Genome Project, the draft of the Human Genome was only 2003. So her name is Rosengil Garrison. And 3 years before the world was even talking about the human genome, she started the first company called Saona that said, we can look at genetics and we could come up with better nutritional recommendations based on understanding your genes. Well, there was something magical about it for me, and something about it that I had a sense would give me the answers that I'd been looking for when I started my journey. And so I landed up being the second employee in the company, stayed with Saona for 7 years, moved to Boulder, Colorado to work with her. But I also realized that genetics was really complicated and that I didn't have that knowledge. So I did go back to university and I did a PhD in genetics. So I did in the end land up with, and my PhD was very, very focused on this word nutrigenomics, which is nutrition genetics. And in fact, my area of specialty is obesity. So studying why do some groups, some individuals land up being obese despite what they may eat or not eat. And that's really the beginning of my journey. And I wouldn't say it brought me here, but it brought me into the world of nutrigenomics. And then that journey has all been about education, teaching, building genetic tests, working with practitioners. And that's how I find myself here today.
So I'm curious, since, working with genes is a fairly new process, how do we make different correlations between different health aspects and genes? Like, what's the process of that? How do they figure out which specific gene is for X condition, or what nutrients would work better for X gene, etc.?
Good, great question. I'm going to have to take you back a little bit to the beginning. So if we think of our genetics as our blueprint, it's like a book written about who we are. And the writing in the book might be 99.9% the same, but they're going to be part of our story that is written differently. So what happens is we have this code, this genetic code, and this code makes every single protein that functions in our body. And actually, our body is really about protein, because proteins are about our cell membranes, our hormones, our neurotransmitters, our enzymes, all these things that we hear. And what actually makes the protein is this code. So we have a code that says, you need to make that enzyme, you need to make that hormone. And that is our blueprint. That is our DNA code, right? And when we make these proteins, we make them 99% of the time identically. So your proteins and my proteins will be 99.9% the same. But at 0.1%, our code is different, which means when we make our enzymes and hormones and proteins, there's going to be slight differences. Now, the interesting thing is it's these slight differences that actually make us who we are, but also make us different in how we respond to the world around us. So I'm going to give you an example that will answer your question better, which is, what is that connection? So we have a DNA code, and this code wants to make a hormone that is called, I'm going to give it a name, it's called TNF-alpha. And this is a protein that is responsible for increasing inflammation in the body. So tumor necrosis factor is a protein. It has a code in a gene in our body. And when we make this protein, if this protein gets switched on, expressed or made, it turns up the inflammation in our body. Now we know that inflammation is actually not always a bad thing. It's got a bit of a bad rap, but actually it's not entirely a bad thing. Sometimes our body needs inflammation to heal the body, especially when something bad happens, like an infection. But when our inflammation is switched on, when the protein, too much of the protein is made for too long, we can actually get sick from having an inflammatory response in our body. Now, if we go back to the code, and I said that you and I have mostly the same code, but slightly different, imagine you've got this DNA sequence, which is just letters. It's the same as the alphabet of English. It's the alphabet of genetics. But I have some different spelling than you have. And when I made my protein from my code, my spelling was a little different from you. So when I made this inflammatory protein, I made more of it than you might have made. So if I can study the code and I can read that code and I can work out whether I've got the spelling that makes more of the inflammatory protein or less of the inflammatory protein, suddenly I understand something about you that gives me an idea of what might be happening in your body. Because if I know that you're making more inflammatory protein, I'm going to start thinking, what are the kind of foods and supplements and changes in your life that I can do to decrease in the inflammation in your body to kind of compensate for the fact that you had the spilling to make more inflammation. Does that make sense?
That does make sense. So with that 0.1% difference, how fast are we seeing that difference change among people and among generations? Like what type of adaptations are we seeing in that 0.1%?
Yeah, so again, great question. So this is an area called evolutionary biology, which is what you speak about, which is which is Darwin. I mean, this is Darwin. How do we respond to our environment? And the interesting thing is, when we look at where we are in our health, where the Western civilization really has got quite terrible health at the moment, especially lifestyle diseases, diabetes, obesity, inflammatory conditions, autoimmune, heart disease, we're seeing so much of it. What we're seeing is that actually the genetic code changes very, very slowly. So the code we have now is kind of the code we've always had as hunter-gatherers going back right to the beginning. But our environment has changed significantly. So the speed of change of DNA is actually minute. You might land up in your lifetime with a few changes to your spelling, but generally it would take generations and generations of an exposure to sugar, to carbohydrate, to pollution, to stress, to start getting those spelling changes. But the problem is our environment changed so quickly. So the way that food changed so quickly, we went from growing our food and eating wholesome food to suddenly having these extremely highly processed, sugary, corn syrup foods. And that is this disconnect between our genome, which is actually quite ancient, and our environment, which is quite modern. And there's this conflict is actually what's causing this incredible rate of what we call lifestyle diseases.
Yeah, it's kind of interesting because I had great grandparents that lived almost to 110 years old.
Wow.
And then generations later, we're seeing age changing at the time of death. So it's like, the world has changed so much in 110 years that they might not have had as much exposure to pollution and different environmental toxins that are potentially out there. And now we're having a tougher time dealing with that. So it definitely makes it interesting how much of an impact the stuff that we're doing on this planet can impact, our life and just in general.
Absolutely. So it's not always the obvious stuff. I mean, we know about sugar, right? We know about corn syrup, but it's as you say, it's actually there's a lot more to it. It's what's in our water. It's what's growing in our fields. It's what's in our soil. It's our stress environment. It's what's happening in our ozone. There's so much we don't understand about how we always say that every single decision and exposure that we have in a day, and we make thousands of minute decisions a day, impacts our DNA. So it changes the way our DNA behaves and expresses itself, but it also means how we respond to those decisions. So, I'm pretty sure that our 110-year-old ancestors were not drinking cup after cup of caffeine all day. It was hard work to get a cup of coffee. You had to work hard to get your coffee, So it's just, there's so many, it's not always these big things that we think of, but actually the small decisions that we make about where we live, what house we live in, what transport we take, how we manage our stress. Even overtraining, over-exercising, endurance training has an impact on our DNA. So it's this whole environment that we find that is really creating this disconnect between our ancient genome and our environment.
Yeah, and now I'm curious your opinion on this, because a few years ago there was a study where they tested the umbilical cord of a lot of pregnant women and found over 200 plus toxins that the baby is exposed to before they're even born. So what do you think, being exposed to toxins like that even before you're born and you're in that development process, what do you think that is doing to the genetic code?
Yeah, I mean, that's it. So, your DNA is sitting there from the moment there's an egg and a sperm. That's where your DNA starts. And so any exposure, and what we know is that a lot of environmental toxins actually, they create something called DNA adducts, which is like a fancy research word. I think of it as like potholes in your DNA, little mini breakages in your DNA. And every time we're exposed to toxins, we create these little breakages. And generally our body is able to fix the breakages. But if our exposure is very, very high, then we don't actually fix these breakages. And so when we replicate our cells, when we make more cells, these breakages, minute ones, get born into the next generation of cells and the next generation of cells. And when we see cancer incidence, so these breakages are directly correlated with the incidence of cancer, right? So when we start thinking about toxins affecting our DNA integrity or DNA wholesomeness, so right at day one, you can imagine how we're increasing our risk for things like autoimmune, but cancer at earlier ages, which is what we're seeing. Because, if you're in a prenatal stage, you've really got to clean out the diet. You've got to be able to remove environmental toxins for the exact reasons that you're saying, because it's not, these diseases don't start when they get diagnosed. You don't get cancer when you go to the doctor and the doctor says you've got cancer. It took you 20, 30, 40, 50, 60 years to develop cancer. And where it starts is where we get this DNA being impacted by the environment, which causes these macro changes, which then get built into our system.
Do you think with super early exposure, like in the umbilical cord, that our bodies would be able to adapt and change in a way that it causes less damage being exposed to those types of toxins and pollutants?
So I think there's always stuff we can do, even at that point. So there's always stuff, because we now understand how to switch on and switch off different genes. So we know that if there's been exposure in the umbilical cord at that point in the pregnancy, we can treat the pregnant woman to be able to switch on genes that detoxify environmental toxins. We have beautiful foods that can do that. We have some nutraceuticals we can do that. So people always say, like, is it too late when I'm 70 to do a genetic test and find out how I manage toxins in my body? I'm like, it's never too late, and it's never too early. Because it's the same with the inflammatory story. Like, know who you are, understand what you're bringing into this world, both from a genetic sequence point of view. So know your spelling changes. If I use the same, know your spelling changes, know your propensity you bring in, understand what your environmental exposure is. Because if you have those two pieces of information, you can actually make some really incredibly powerful diet, lifestyle, and environment changes to compensate for it. So you really can do an amazing amount. I mean, things like trauma, all those things, if we know about it, if we know our genes, we can always do things to bring us back to a better baseline.
Now, let's transition into talking a little bit more about how our genes and the foods that we eat can play with each other. So what type of genes are you looking at to see what type of foods are better for someone and what type of foods are something that someone might have more of an issue with?
Okay, let's talk about, let's see, let's start with salt. So there is an entire industry that is very profitable on selling low salt foods or low sodium foods. And in fact, if you look at the dietary guidelines for the country, they'll tell you that you must eat less salt. But if you look at it through a genetic lens, what we actually come to understand is that about 50% of the population have no response to salt whatsoever. So you can eat cupfuls of salt and your blood pressure will not budge, And in fact, you can have high blood pressure, reduce your salt intake, and your blood pressure will not budge because genetically you're not responsive to salt. Okay. So often in nutrigenomics, another word I love to use is responsiveness. How do I respond to salt? So salt is a perfect good idea. Caffeine is another excellent example. We know that there's certain individuals who will drink caffeine all day. They will have a double espresso before they go to sleep at night, and it will have no impact on them. Others, like myself, I have to have my caffeine very early in the day, because if I load up too much caffeine, I feel very agitated, I feel restless. This is, remember we spoke about the spelling change? So there's a spelling change in a gene called CYP1A2. And when CYP1A2 makes the enzyme that breaks down caffeine, metabolizes caffeine, I have a spelling change that means I'm very slow at breaking down caffeine. And you may have the version of the sequence that you're really efficient at breaking down caffeine. We can test that in a genetic test and be able to give you insight on how you break down caffeine. Another one is gluten. Everyone's gluten crazy, right? So interestingly, how we break down gluten and manage it in our body is very genetically driven. So we can actually look at genes that tell us if our body is unable to metabolize and utilize gluten, and that's why we get an adverse reaction to it, and gluten has such a bad effect on our gut. That is actually genetic. Vitamin D. There's some individuals who, even though they will be exposed to enough sunshine, clearly not in Seattle, but in a sunny country like South Africa, I have a huge exposure to sun. And yet, when I measure my vitamin D levels, they're low. And that's because genetically, how my body, and remember, vitamin D is actually like a hormone. It's much more than a vitamin. How my body metabolizes vitamin D, how it converts vitamin D, is governed by these spelling changes. So what I'm kind of getting at is that there's no one recommendation for an individual. There's no one dietary guideline, because actually we all respond totally differently to different foods. And if we understand what our response is to all kinds, vitamin B, folate, choline, I mean, I'm just thinking of all of them on the top of my head, we all have a differing response to others.
And are you able to look at the genes and assess like specific types of foods, carbohydrates versus proteins, if someone would do better on a low carb, high carb diet, low fat, high fat, etc., that type of stuff?
So there are quite a few genetic testing companies in the industry who in their genetic reports will tell you that they can tell you what percentage of carbohydrate or fat or protein. I've been doing this for 20 years and I still do not believe that is so. So while we understand responsiveness to different foods and how the body interacts with different foods, the idea that we can, in isolation of knowing who you are and what your goals are and your medical history and what you're trying to achieve and I do not believe that genetics right now can give you that information. I can give you information about the quality of dietary fat you should have. So the kinds of fatty acids you can have, the better kinds of carbohydrates you can have. I can even give you some information about the proteins, but what I can't tell you is whether the proportions should be 70%, 60%, 40%. There's some things I can understand around high fat versus a low fat diet, but I would never take it so far as to say, you need to go down to like a super low carbohydrate is going to be better for you. I think that that's pushing the science a little bit too far.
Yeah, I've seen some people test with multiple different genetic tests in the States here, and they'll get the results back and they'll say the complete opposite for like their carbohydrates and their fats and proteins. So I've always been curious about that. Yeah. And I feel like the science quite isn't there yet. And I feel like a lot of those companies just want more markers on their paper to show you, hey, look at all the stuff that we ran for you. So that's why I was asking that question.
Yeah, I agree with you. I think the science has grown a lot, but we have to be so careful that we keep genetics in context, that we don't overreach the science, that we capture the gems of what genetics can give us, but we don't pander to the marketplace to be able to sell something that will actually, in the long term, undermines the science, if that makes sense.
Yep. Yeah, the same thing is happening with the microbiome too, because you'll do a microbiome test, a stool test, and that's a snapshot of that specific moment on that specific day, and it'll give you a giant report that this is what you should eat, blah, blah, blah. Well, your microbiome could change tomorrow, and based off of those results, it could be completely different.
Yeah.
So, yeah.
Well, I mean, the microbiome is another conversation, but the microbiome, like genetics came first, the microbiome came second, and we're still learning so much about genetics that how to give recommendations. And the microbiome is like 10, 20 years behind us. So for my challenge with the microbiome, while I do think it's going to play a fundamental part in the future of health and humans, we're still trying to understand how to interpret the data. So there's a difference between collecting data and translating data. And the great challenge of genetics over the last 20, 30 years has been measuring genetics is one thing. Just because you can build a technology platform that can test our genes doesn't mean we know what to actually tell you to do. And you made an excellent point earlier about companies that just load stuff into their genetics, because if you're paying $200 or $300 and you're getting 1,000 genes, it must be better than a test that's got 100 genes in it. And in fact, it's the opposite. Because what happens with these companies is, and it's happened a bit with microbiome as well, is that they load up their genetic tests with genes because the price of testing has come down. So I can actually give you 600,000 genes for the same price as 134 genes. But I can only clinically translate 134 of the 600,000. So if I gave you 600,000, I would actually be giving you data, but no value, if that, right? But if I give you 134 that I know how to interpret, that are informative, that will give you information to bring into your life, to choose your foods, to choose your lifestyle, then I'm creating value. And that is the exact problem where we have in the genetic testing industry. And it's also happening in the microbiome, where just because we can test it doesn't mean we've worked out what to tell you to do with the data. And microbiome is really battling with that. And exactly your point, at least genetics doesn't change, right? So if I test you today and I test you in 20 years, I'm going to get the same report because your genes don't change. You might have like one little spelling change in a lifetime, but it's marginal. But of course, as you said, your microbiome, you could actually travel to Japan, and after being in Japan for 28 to 45 hours, if you do your microbiome, it will change. So that is the challenge that we have.
Yeah, and that I watched one of your videos, and I'll link that in the show notes as well, where you were talking about kind of the future of healthcare and a lot of more AI based. And I could totally see in the future that whatever systems that are available have your genetic sequencing in place. And then when you go to the bathroom, number 2 in the morning, it'll automatically test your microbiome, and then you'll get like a 3D printed dietary supplement or something like that is specific for you. So what do you think about that?
Yeah, I do. I mean, I do think the future so the future has to be about how we manage to translate data, not just data. So we've had this like data revolution. We're obsessed with data, big data, right? We want to test people and we want to sell it. But the challenge we have is what to do with it. Now, I think what's happening and what you're describing is the future, where genetics will always be your baseline, but then you want to see what's happening in your gut. Then you want to see what's actually happening with your protein levels, right? And then you want to make decisions based on all those different things. And so at the moment, we're making decisions or giving recommendations based on genetics, and then some blood tests that your doctor would send you for, some urine tests, some other tests. And as a practitioner, I'm going to look at your genetics. I'm going to look at your blood tests from the labs that you've been to. I'm going to ask you a whole lot of questions, and I'm going to make decisions. What's going to happen in the future is we're going to have layers and layers of data. So I'm going to be able to extract much more information from your microbiome. Exactly as you go to the bathroom in the morning, it's going to measure it. Urine test, it's going to tell me like your glucose, your insulin, your adiponectin, etc. And we're going to, because we have much better AI and machine learning, we're going to be able to put them into kind of a more systems approach where we can layer information. And that is definitely the future. And at the moment, it's happening in the research world, where we're starting to build these layers of data and trying to figure out how they talk to each other. but it's definitely not ready for the commercial world. I think we've got some time to go still.
Yep. 50, 100 years. Probably not in our lifetime.
Don't know. You look younger than I do. I don't think it's that far. I think in the next decade we'll start seeing it. I do think in the next decade we'll start seeing it.
Wow, that's going to be quicker than I thought.
I think
interesting.
Yeah.
So another question I had is dealing with epigenetics. So just because you have a gene sequencing doesn't mean that that gene is going to express itself.
Yeah.
So how does that play its role in the type of foods that you eat?
Okay, so epigenetics is a word that everyone battles with, even practitioners who've been working with me for years. So I prefer to talk about, let's just go back to basics. So we have a DNA sequence, which is our code. It's our blueprint. We're born with it and we have it for our life. And this code makes proteins. But something has to tell the body to switch on the gene. It's like a light switch, right? I walk into the room and I switch on the light and the light comes on. So something needs to tell the body to switch on the gene to make that protein and whatever that enzyme or protein or hormone or neurotransmitter is. And this is the process of epigenetics. What is in our environment that is sending a message to our DNA to either switch on or to switch off. And sometimes we even have master switches where we can, you walk into a house and it's got like a master switch and you switch it on and it switches on all the lights. We have that in genetics as well. In fact, we have this amazing, what we call a transcription factor called NRF2, which is a mega switch. And when you switch it on, it switches on about 500 genes that are all what we call defense genes, detox genes, anti-inflammatory genes, antioxidative genes, fantastic genes. So epigenetics is what we call, epi is outside of, so outside of genetics. What is the thing that is happening that is talking to our genes that is switching them on or switching them off? And it's a very complicated process where it puts like a little, like a chemical marker onto the gene, and that when a gene gets tagged with that little chemical marker, it wakes it up, it unravels, and it makes a protein. Super smart. So when we do nutrigenomics, what we do, we actually work in both spaces. We want to look at the DNA sequence and understand who you are, what are your spelling changes, but we also want to use epigenetics or gene expression, as you said, to be able to help you to make the best possible decisions. So I'm going to give you an example of epigenetics and why it's so powerful with food. So we do a genetic test on you, Brian, and we discover that there's a couple of genes in your detoxification pathways that are not functioning optimally. So you have some spelling changes that mean when you go in flight to Beijing and you suddenly have this exposure to this huge amount of pollutants, your body is, okay, most people will not be really good at dealing with Beijing, but you particularly are going to have a problem of processing those pollutants which are coming into your body and getting them excreted and expelled from your body, right? You're just not a great detoxifier. Now, if I know that about you from your test, I want to use epigenetics to try and compensate and fix that. So what we know is there are some fantastic genes in the detox pathway. And if we can switch them on kind of manually, right? Intentionally go and switch them on, we can improve how efficient you are as a detoxifier. So there's a family of genes called the GST genes, the glutathione transferase genes. And these genes are very, very potent in terms of grabbing that pollutant molecule, binding it, converting it to be water soluble so that you can get it out your body. And we know that there are certain plant molecules, what we call bioactives, but they're really plant molecules that can switch on those genes. So an example of those are plant molecules found in our cruciferous vegetables. Cruciferous vegetables, broccoli, cauliflower, kohlrabi, kale, all those, okay, but main ones, broccoli, cauliflower, cabbage, those are the ones that you're mostly going to be eating. Brussels sprouts is obviously another one, and broccoli sprouts. And we know that there's something in there called glucosinates, and this compound, when it enters your body and you eat it raw and you chew that vegetable, so that's the tough part, raw and chew, it switches on these GST genes, and it switches on your detox processes and helps you clear the pollutants. So next time you go to Beijing or anywhere pollutant, you pack your cabbage and your cauliflower and your broccoli and you snack at it all the time. Or we find you a very nice supplement that does the same thing. But that is an example of how we can use a nutrient, in this case, a plant molecule, to help genes express in the way that we want to. Because the problem is, that's the positive angle. The negative angle is when I do go to Beijing and I have the pollutants, those toxins are going to switch on genes or switch off genes that are going to have a negative impact. That's also epigenetics. So one side of the coin is know who you are, know what genes you were born with, know which your areas you want to focus on. The second part is making choices in your life to switch on and switch off genes that are going to help you manage that health.
Wow, that was an amazing explanation on how all that works. Thank you for that. Thanks for really breaking that down. Yeah, and that just shows kind of the complication, but also the beauty of getting these type of tests done. And I do want to talk about the test that you have available at 3x4 Genetics. Can you talk about what it is that you're doing over there and who is able to get those labs?
Okay, so I've been building genetic tests for 20 years, and about 5 years ago, I hit a wall. I just felt that I hadn't done my best work. And in fact, I believe that when I look back to where I started around my gran and the cancer, that really I'd lost my way. And one of the reasons was, it's kind of come back to our previous conversation, which is that I was building genetic tests that were being led by scientists. So I, as a scientist, was determining how the test would look, how it would, what would have in it, who would sell it, etc. And I realized that to be valuable, data has to be translated into a way that both a practitioner, a dietitian, or a doctor can use that information, but also for the person who paid for that genetic test, it has to be something they can engage with, they can understand, it's meaningful to them, and also tells them what to do. So I went very much back to the drawing board, and I went looking for a partner who would help me build a genetic test that wasn't just based on the science. And my business partner, his name is Jason Haddock, and his background, I actually found him at a gaming company. He was the chief technology officer in a gamification company, and they did behavioral gaming. So not Candy Crush, but how do we use gamification to change human behavior? And that for me was exactly the answer, right? Because we know that genetics gives you the most amazing insights to change your daily behavior, to live a better and healthier life. But no one had built a genetic test that would inspire you to make those changes in your life, because it just looked like a PDF with a table in it with some letters. So Jason and I set off on this mission to bring design thinking, user experience, consumer-centric innovation into genetics to say, how do we build a report that a practitioner will love to use because it's easy for them to understand, but also it's easy for them to use with the patient? We also made a decision that we would only sell our genetic tests through healthcare professionals. And we did that because there are many, many companies in the market that you can go online, put your credit card details, get a genetic test, send it off, and get your report. But genetics, it does not live in isolation. Genetics is a piece of a puzzle of who you are. But there's lots of other stuff. Your childhood, your background, your goals, your dreams, your current health concerns, your training, your stress response. So when I build a genetic test, I'm not able to guess what those things are. So when I give you a report that tells you what to do, how do I know that I'm actually speaking to you? So I wanted to work with practitioners who did know who you were. I would give the practitioners the genetic piece of the puzzle, but the practitioner would fill in all the other information about you. So that's the first thing. We work with practitioners who we train and we mentor and we help use genetics in their practice. The second thing was around the design innovation. We built a genetic report that is based on two things. One is color. The whole report is based on color. So there's a language of color, and we talk about following the purple, where you can literally track a color through your report so that you don't need to know the science. You don't need to know the genes. You just need to follow the purple to the areas that are most impactful and meaningful to you. We did something else. We created something called pathway-based analysis, which is the only company that has launched that in genetics, which said these genes by themselves, you can't make these life-changing decisions based on a single gene. You can't say, well, I'm going to start eating 20 portions of cruciferous of broccoli a day based on a single gene, because there's so many of these genes. So what we did was we grouped the genes together and we said, what are all the genes that work in detoxification? Let's take all the detoxifications, group them together, and see when we score them as a grouping, how much is your detox impacted? Because all the other companies in the marketplace, they will give you one gene and they'll give you a diet recommendation and probably a supplement for that gene. But the reality is you have 10 or 20 or 25 detox genes. So we grouped them and we built pathways. So we have 36 pathways for everything from detox and inflammation to glucose and insulin to estrogen to sports prowess, how your VO2 max works, how you more likely to be injured when you do training, to vitamin D and caffeine, all pathways. And they are grouping our reports. And finally, the thing we did, which I love the most, is we built what we called a visual conversation. Because when I was in practice, which I was for a very long time, every time I tried to explain a genetic report to a patient, I would draw pictures. Because understanding detox or inflammation or methylation, very tricky one, is extremely difficult. So I had all these pictures I would draw, like a story. So when Jason and I were building this board, we thought, well, if I'm drawing pictures all the time, why not build pictures into the report? And so that's what we did. Our report is based on what we call infographics, but they're really storytelling visual conversations that show you in a visual way what is detox, what is inflammation. The practitioner then is able to tell the story of what's happening with you. And every single infographic changes for every single patient. So depending on your genetic results, your picture looks different. And so it gave the practitioners a way to have a conversation with the patient that was about storytelling and pictures and not about data. And this is why, one of the reasons why we really have created a completely different paradigm for working with genetics, which is bringing the best elements of design, technology, design thinking, behavioral change, and trying to bring it into the world of genetics.
Awesome. And practitioners that are listening, they can learn more at 3x4genetics.com. There was a couple other questions I wanted to cover. First one is, are there any common misunderstandings around DNA-based dieting that you think people should know?
There are lots of misunderstandings around dieting. So dieting and genetics is my favorite area. So the bottom line for genetics, we could talk for like an hour just about genetics of weight, is that when I trained as a dietitian, I was taught that calories in, calories out, that if we reduce calories and we increased expenditure, absolutely everyone would lose weight. We were also taught that if a patient came to us and we put them on a diet plan with reduced calories and they didn't lose weight when they came back to us, it was because they were lying to us. They had cheated and they were lying. And there was never an opportunity for us to think that maybe actually they had reduced their calories, done everything we told them, but they hadn't lost weight. So one of the most exciting things for me in the world of genetics is understanding how people gain weight differently and lose weight differently. In fact, it's way more nuanced than that. We actually are driven to eat differently. So we can take a bunch of our best friends and go to a buffet restaurant and stand in front of those tables loaded with food. And they're going to be some in that thing who go, oh, I see the food I like, fill up their plate, go to the table, finish it, and they go, I'm done. And they're going to be a group there and go, there's more food, I'm going to get more food. I'm going to get more food. And they go back to the buffet table and back to the buffet table. Now, originally, we used to say they're greedy. They've got low willpower, lack of self-control. But the reality is way more complicated than that. Our genes drive our eating behavior, binge eating, snacking. You don't have to have a whole eating disorder, just something around the buffet table, how often we snack, how when we see food, what is our level of control? We also experience hunger differently. We don't all get hungry in the same way. We don't all get full in the same way. So how can we say that there's a diet plan for this person? We can feed people the same diet plan. One person will lose weight and keep the weight off. Another one will lose weight and gain the weight back. And another one won't lose weight at all. And they all be doing the exact same thing. So one of the best things about the genetic report that we work with is trying to understand the individual of how they engage with energy that goes into their body, which is the eating, how we store energy in our body, and we all store differently. Some of us hold on to that energy and don't want to let out our body, and how we burn up energy. There's a whole world of complexity and nuance in understanding why one individual eats in one way, gains weight, and loses weight. And there is definitely no judgment about how we respond to that environment.
Awesome. And then my final question for you is, what is your vision of what healthy looks like, and what are 3 things you do daily to reach that vision?
So I'm not a hardcore health person, but bizarre enough. I believe that my idea of health is really about finding your earth, and I mean that like a plug point. And it speaks back to what I spoke about the weight. You've got to find your truth to be healthy. You cannot find someone else's truth. And it may be that your body weight is going to be higher than everyone you know, but it may be your genetic truth. And then you work in that world. You say, well, if I'm going to be that weight, what does health look like to me in that space? Well, I'm going to eat a lot of veggies. I'm going to exercise a lot. And that's the truth comes back to the exercise story. We are not all meant to be endurance athletes doing 100-milers. We are not all meant to be doing CrossFit. We've got to find the thing that resonates with us. It's like a frequency. It's tapping into frequency from how we manage stress. Not every person who's told to meditate is going to meditate. I do not meditate. It's not my thing. You have to find your thing. So my thing is I am deeply passionate about cold water swimming. I will swim in anything that's deep enough for me to get in and cold enough. And when I found that, I found a way to manage my stress, to calm myself down, that some people use meditation. I found an exercise and a sport that I loved and felt comfortable in. I found a social connection. So for me, that ticked a whole lot of health boxes. So for me, there is no one health. And the journey of genetics is a journey of self-knowledge, of finding what your health world ecosystem looks like, and not falling into the trap of social media, of what the latest trend is, or how many calories, or Peloton, or I've done 1 million miles this week. And for me, I've always very, very careful about that.
Awesome. Well, people can find more about you at 3x4genetics.com. You also have your 2 books that I will link to in the show notes. Are you on any social platforms as well?
I am. I'm not very good at them, but I'm on Instagram. I'm on Facebook. Well, actually, probably Instagram is best. And LinkedIn. I love LinkedIn. So if you really want to find me, you'll find me at Yael Joffe, at 3x4genetics, and you'll find me on LinkedIn. That's the best way to find me. You can also email us at info@3x4genetics.com. It will be definitely forwarded to me if you want to speak to me directly, or go to my team. But that's probably the best 2 ways, email and LinkedIn.
Perfect. Well, thank you, Dr. Yael, so much for coming onto the show. I appreciate it. I love this episode. There's so much information about genetics, and I'm so excited to see the direction that understanding genetics is going to go in the future. So it's really cool that you were able to come on and just share, what's going on right now and the direction that it's headed. So thank you.
Thank you very much. And thanks for having me, Brian. Great being here.
I really enjoyed this conversation with Dr. Joffe. I'm glad she was not afraid to say that there is still a lot for us to learn about nutrigenomics, and if there isn't enough research to fully support a claim, then she wasn't willing to recommend to follow that claim at this time. If you are interested in taking one of the 3x4 genetic tests, feel free to reach out to me and I can help get you all set up for a test. Now, next week, I have a three-peat guest on the show, Cynthia Thurlow. Let's go learn what we will be talking about. I am here with Cynthia Thurlow. Hey, Cynthia, what is one unique thing about you that most people don't know?
Oh, goodness. I would say, and this is kind of an embarrassing thing, but it's so out of character that I think it would be probably funny. When I was in college, my sorority sisters convinced me to become a Hooters waitress, and I didn't know what that was. And so for about 6 months when I was in college, I was a Hooters waitress, and it's about as far from who I am as an individual, but it kind of shows you I've got a playful side.
I don't know if there's many Hooters left, so I feel like we're about to enter a generation that has no idea what that is.
Yeah. Definitely not the most PC thing in the world. I remember I was like, you want me to wear what?
Well, what will we be learning about in our interview together?
We will be talking about ways that people struggle with weight loss, which is probably the most common reason why people want to work with me.
And what are your favorite foods or nutrients that you think everyone should get more of in their diet?
Ooh, I think first would be some fatty fish. So I think about salmon and sardines and tuna because we need more of the omega-3s and less of the omega-6s. So those fatty acids. I would also think about consuming more cruciferous vegetables, probably not the most sexy topic, but like Brussels sprouts and cauliflower and cabbage. Like I'm on a total cabbage obsession. And then I also think about, I had some really good ideas when I was thinking about this earlier. I would say, the other thing is, really focusing in on, selenium rich. So that was one of the cofactors for thyroid hormone. So selenium rich foods, I always think about like Brazil nuts and things like that can really be very nutrient sourcing for your thyroid.
And what are your top 3 health tips for anyone who wants to improve their overall wellness?
Ooh, high quality sleep, 7 to 8 hours in a cold, dark room, eat less often, doesn't necessarily have to be intermittent fasting, and get some sunlight every single day. I know depending on where you are in the United States or abroad, there may not be as much opportunity to have bare skin, but vitamin D synthesis is really critical. So getting out in the morning helps to reset your circadian rhythm. And also you have receptors in your retina that help remind your body that it's time to get moving.
It is always a pleasure to chat with Cynthia, and if you want to learn how to break through weight loss plateaus, then make sure to listen in next week. So until then, keep climbing to the peak of your health.